cockle shell powder. Okay. So banana skin powder and cockle shell powder. Banana skin powder has been found it has been, when we conduct the chemical composition test, the result shows that the banana skin powder has high amount of silicon dioxide. Okay. And a very small amount of calcium oxide. As for the cockle shell, the chemical composition of the cockle shell powder, the result shows that it has high content of calcium oxide and very small percentage of silicon dioxide. Okay, between these two materials, which one is suitable to be, which most likely to be called as pozzolanic material? Between these two material, dua-dua pun you tak pernah belajar. Based on, now you are going to assess based on the chemical composition. Okay, so which one that most likely would be the pozzolanic material in this case?
Banana skin, Doktor.
Okay, banana skin powder. Okay, so ada orang tanya pula, betul ke banana skin powder ni ada pozzolanic ash? Ada. Okay, recent study shows that banana skin powder which has been subjected to high temperature incineration and ground to be powder has high content of silicon dioxide. Okay, research dekat UTHM. Okay, same goes for the bamboo ash. Okay, so kalau material tu tidak ada silicon dioxide, okay, tak ada ferrum oxide, tak ada aluminium oxide, okay, dia punya percentage adalah very small dan dia punya dominant, yang the dominant composition adalah calcium oxide, dan benda tu tidak boleh dikategorikan sebagai pozzolanic material. Pozzolanic material according to ASTM C618 is already stated that it has high content of silicon dioxide and very small percentage of calcium oxide. Dia dah bagi tahu clear kat situ. So that's the thing that you need to refer. So kalau barang tu tak ada silicon dioxide yang tinggi, okay, dia punya calcium oxide pun sangat rendah. If dia punya silicon dioxide dia sangat tinggi dan calcium oxide very small, okay, very small percentage, then the possibility for it to be classified as a pozzolanic material is high. Okay, as compared any other material which has high content of calcium oxide. Contoh macam eggshell powder. Contoh macam cockle shell powder. Okay, kalau cockle shell powder pun bukan powder yang grind tu, dia kena bakar dan jadi cockle shell ash lah. Okay, cockle shell ash ke, oyster shell ash ke. So all those things dia punya content of calcium oxide yang tinggi. About 90%, ada yang 80%. So that one kita tak boleh classify dia sebagai pozzolanic material. Okay. Kena faham lah that definition. Okay. So try to do this question. Okay, soalan ini it can maybe somebody will ask you analyze the result or evaluate the result, evaluate the case, assess the case. Okay, so and the marks is 9. So apa agaknya nak ditulis?
Kita compare tu. Kita compare, lepas tu kita mula cakap pasal kenapa yang Yang ada
Dia tak ada
pozolanik tu.
apply dah. Dia dah tunjuk dah kat
Apa?
situ. Result dah
Oh.
ada kan?
Result dah ada.
Result dah ada. Ni nak cakap apa ni?
Kita mention kenapa result, kenapa
Yes.
dia buat.
Yes. You need to explain why. Why the result is like that. Okay. So, boleh, and can anybody explain why, how many points is needed to get that 9 marks? Can anyone explain apa yang rasa-rasanya nak dicerita dalam kes ni? Nah, ini soalan yang basic lah. Soalan kalau ditanya pun soalan yang belum susah ni. Ini baru soalan biasa. Okay, what makes that blended cement concrete mix tu yang ada blast furnace slag tu can have higher resistance, higher durability than plain concrete? What could be the reason?
More compact due to extra CSH gel coat.
Bukan kot, betul lah. So, in this case, the question already give you the answer that the concrete cubes were prepared by integrating suitable, adequate content of slag. Kita bagi kita suitable. Kalau soalan tu cakap integrate slag tapi tak cakap apa-apa, you tengoklah. Dia mungkin ada trick kat mana-mana. Then katakan soalan kata, then the cube were cured for 60 days. Maybe curing dia tu pun point tak ada kat situ. Okay. So macam ni dia dah bagi tahu water cure for 60 days. So pozzolanic material needs water curing. Okay, it performs better when we use a water curing method. And here what you need to explain is how you need to explain the role of pozzolanic reaction in enhancing the durability of the concrete mix as compared to plain concrete. Apa benda nak cakap sekarang? Okay. Boleh sesiapa mengarang dan cuba jawab. Mila markah kan?
Nak try tak?
Okay, cuba.
Mula kita mention pasal pozzolanic reaction takes place dalam
Explain. Apa benda tu? Cuba cerita sikit tentang pozzolanic reaction.
Okay. Pozzolanic reaction will occur in the cube containing the ground-granted GGBF slag, and as the cube is cured in water for 60 days, we know that pozzolanic reaction requires moisture, and then pozzolanic reaction can cause the addition of secondary CSH gel, which will fill in the voids in the concrete, in between the concrete. This
In
will
between the concrete.
in between the particle.
Okay.
Patut salah. Betul. In between the particle.
Okay.
This will result in higher durability of the concrete containing the furnace slag. Lepas tu, itu.
Okay, ada satu point lagi tercicir. Tak masuk lagi tu, ada satu lagi.
Less permeable.
Yes, okay, less permeable because of the formation of extra CSH gel that create a more compact concrete. Okay, lagi?
Which will cause any acid acid resistant. Hard
Mana
for
boleh
acid
tensi
to
tu sodium sulfat tu.
for sodium sulfate.
Ha.
More resistant to sulfate attack.
Okay, lagi?
Support charge.
Lagi? Ada lagi satu point tu. Ada 26 orang kat sini. I believe some of you have the information. Okay, you need to compare. Okay, yang tadi satu information tu tak mention lagi yang okay. Cuba cari lagi satu jawapan. Okay. Then you need to compare with the performance of normal concrete. Okay, you need to mention about the what are the reaction that present in the concrete containing slag, which is the hydration and Pezzolinic reaction. If the concrete only depends on Pezzolinic reaction, tak mungkin. It has two reaction that contribute to the formation of larger quantity of CSA gel. Kan? On the other hand, yang control concrete only rely on the formation of CSA gel through hydration process. So when we compare in terms of the which one is more compact, the internal structure, is definitely will be the slag. Itu satu. Lagi satu apa? Ada lagi satu point.
Kena mention pasal CaOH ke doktor?
Yes, because durability kan? Kena mention. Okay, so the occurrence of Pezzolinic reaction has basically would consume the calcium hydroxide, which is vulnerable to any aggressive agent. Okay. On the other hand, the calcium hydroxide which has been produced in control concrete will not be consumed. Okay, thus it will be attacked by sulfate ion, resulting in production of ettringite and gypsum, which in turn causes the concrete to have some defects. Okay. Dia kena buat tau, soalan mesti ditulis tau, soalan mesti. Jawapan, you all kena buat jawapan. Kalau tak nanti, kalau dah bincang dalam kelas ni pun macam mana? Kena ni lah. Macam mana nak jawab nanti? Okay, cuba buat soalan yang ini pula. 5 minit 5 minit cuba buat soalan.
Alright,
Okay, cuba jawab. Lama sangat kan, tertidur pula. Okay. So what would be the answer for this question?
Madam, can I have a try?
Okay, sure.
Okay, based on the results in the table, the sample mix 1 with the usage of rice husk ash has a lower compressive strength compared to sample mix 2 with the plain concrete. Firstly, there are chances for inequivalent percentage of rice husk ash used because they only stated that certain, and maybe the certain percentage of rice husk ash used is not up to the optimum level which is needed to be added to produce a better compressive strength. Next, when the added rice husk ash is not up to the optimum level, it will never contribute to the strength of concrete. Second, the rice husk ash needs to be burned under high temperature to reduce the LOI level. And also the rice husk ash has to be grounded finely. This is because the specific surface area of the rice husk ash added affects the strength of concrete as well. Only finely sized particles will have to develop pozzolanic activity. So by doing all this, it will help to increase the compressive strength of sample mix 1 as early as 1 and 3 days. Yeah, that's all.
Okay, thank you. Alright. So anyone else lagi nak add?
Nak tambah kan?
Okay.
Pozzolanic reaction requires adequate moisture in order to occur. In pozzolanic reaction, silica oxide will react with calcium hydroxide in order uh, to form secondary CSH gel. So the inadequate of curing of water moisture in water curing will cause the pozzolanic reaction to stop, and the inadequate moisture also will affect the rate of hydration process. That's all.
Lagi? Tu je? Okay,
Tu je.
for this question kena ada 3 point sebab 9 markah. Okay, 3 point. 1 point tu yang Kartini mention tadi. Okay, because they said certain percentage, so we do not know which X percentage is that. So you need to, itu betul point dia, cuma you need to explain lah. Okay, when we use excessive use of RHA or less, too little, it will not, it will affect the strength of the concrete. Okay, due to the pozzolanic reaction issue. If when we use, let's say you can assume, okay, to using too much of, probably it's the use of RHA is too high, so it affects the pozzolanic reaction. As the cement content is greatly reduced, so that will reduce the quantity of calcium hydroxide generated, which is also important for the pozzolanic reaction to take place. So kena elaborate lah, kena elaborate clearly that the excessive, when we use excessive quantity of rice husk ash ke any pozzolanic material, when we use excessively, it will affect, the pozzolanic reaction will be affected due to the less supply of calcium hydroxide for the pozzolanic reaction to take place. So kena bagi tahu benda tu. Okay, lepas tu apa, curing method. Okay, so normally for pozzolanic material, the best curing method is to have a continuous water curing. So that, as we know that the water is important for pozzolanic reaction to occur continuously. Okay, and you mentioned lah, it is important because it will help to generate more CSH gel, extra or secondary CSH gel that will fill in the voids inside the concrete, okay, producing a denser concrete. Okay. Lepas tu ada juga yang cakap the use of rice husk ash which has too little content ataupun less content of silicon dioxide also affect the performance of the structure, the performance of the concrete. You boleh juga cakap probably because of the rice husk ash which have been used is a coarse size. Maknanya size dia kasar. So when the coarse size is used, it will affect the Veselinic reaction. Sebab dia kasar kan, so reaction tak boleh nak berlaku lah. Ataupun the rate of reaction is very low. Okay, so it will affect the strength of the concrete. So how about this question? How about this question? For this case, they ask to propose the suitable type. So, and then you need to compare the benefits of the proposed concrete, compare it with the normal concrete. Okay, so for this case, which is the most suitable type of concrete to be used?
High workability concrete ya?
Yes, high workability concrete. Okay, so the next part will be, okay, so markah dia 5. So satu markah goes for the type of special concrete. Another 4 marks will be given or will be divided between normal concrete and self-compacting concrete. So you kena compare lah self-compacting ni karakternya macam mana. Self-compacting ni karakternya apa benefit dia as compared to normal concrete?
It does not require vibration as it will settle on its own. It will
Okay,
compact itself.
So what is the benefit? Okay, through that, okay, it will, okay, so when it compact by itself, so what is the benefit?
Save cost and labor.
Yes, save cost and save labor. Okay, how about the normal concrete? Kena bincang lah, normal concrete ni macam mana?
As Doctor, can I mention sebab kan congested reinforcement. So bila nak vibrate tu susah nak vibrate belah bawah.
Yep.
Nak vibrate the formwork.
Betul. That's why you boleh lah cakap that it's difficult to vibrate. So kalau compare dengan normal concrete which needs vibration. So when we talk about vibrating the concrete, it is impossible. It's difficult to be done. Okay. So even when it is difficult to be done, even it is done pun, that activity of compacting itself causes extra cost and extra use of labor. Tu satu lagi. Apa lagi? Buka nota self compacting concrete tu.
Dia cair, lepas tu senang masuk dalam celah-celah besi.
Okay, lagi
Tu
compare
je.
dengan normal concrete macam mana?
Self-compacting concrete dia punya aggregate dia lagi kecil lah.
Memang, betul.
As compared to plain concrete which is
Okay.
bigger in aggregate.
Okay, so apa contribution dia?
So the self-compacting concrete can pass through, can go effortlessly in between the reinforcement bars. Macam tu lah.
Okay. Thus produces a structure with a better finishing kan? Sebab dia tak ada masalah, kita akan dapat good concrete with good surface lah. Due to the proper finishing. Sebab dah lah dia pakai aggregate size kecil-kecil. Lepas tu tak payah vibrate. So you just pour, it will compact by itself. On the other hand, Kalau yang pakai normal concrete, you need to do the vibration. If it's over vibrate, your concrete will have problem. Okay, improper vibration or low vibration pun, it will have, the concrete will be affected due to the activity and that will reduce the strength of the concrete. Itu satu. Okay, apa lagi? Kalau kita compare, make sure kita compare dua benda yang sama lah. Kalau kita kata, okay, kalau if you use self-compacting concrete, it will produce a concrete with good finishes. So, you kena compare lah normal concrete. Concrete dia tak berapa good finishes, finishing dia tak berapa cantik. Why? You kena bagi tahu lah kenapa, okay? If you use self-compacting concrete, the site will have lesser noise pollution due to the elimination of compacting activity work and compacting work. On the other hand, if you use for normal concrete which need to be compacted, it will cause noise pollution at construction site. So benda-benda macam gitulah, okay? Alright.
Doktor, yang tadi tu boleh ke kalau kita cakap dia lagi tinggi compressive strength?
Dia kita tak boleh nak cakap macam gitu. Sebab kita bila kita order dekat construction site, kita dah ada dah target strength kita. So normal concrete pun boleh juga. Kita nak apa strength berapa.
Oh.
Tak boleh cakap macam tu lah. Kita boleh cakap dia tak payah nak pump. Kita tak payah nak vibrate. Kita tak payah pump pula. Kita senang nak pump. Kalau normal concrete dia susah sikit. Dia tak ada masalah segregation. Tapi kalau normal concrete dia ada masalah segregation. Okay, kalau pakai self-compacting concrete boleh pakai less worker. On the other hand, kalau normal concrete kena pakai banyak worker sebab kita nak gunakan orang tu untuk compaction work. Gitulah. Okay. So how about the last part? Okay, so last question ni. Kita buat soalan ni sebelum kita habiskan kelas kita lah. Dah lewat dah ni. Okay, how about the last part? Ni soalan dia very direct. The steel rigid fiber reinforced concrete mixing work has been carried out at construction site by unskilled worker. Masalah dia, clumping has taken place. Pertama sekali kena define apa benda clumping Apa masalah clumping? Clumping tu macam mana? Clumping in the mix. Macam mana tu type dekat Google. Clumping. Steel fiber reinforced concrete clumping.
Clumping tu dia macam tak cukup air tu. Dia berketul.
Tak. When we talk about steel fiber reinforced concrete, where the clumping will take place?
Oh, doktor, clumping of steel fiber, doktor.
Yes, clumping of steel fiber. Okay. Actually, clumping of steel fiber. Kenapa clumping of steel fiber tu terjadi dalam kes ini?
Not mixed well.
During mixing.
During mixing. Apa yang berlaku sebenarnya?
Come on, JJ. JJ kata not mixed well during mixing.
Okay, betul lah, not mixed well. Not mixed well tak berapa tepat. Dia ada satu mistake lagi tu. Memanglah tak mix betul lah jadi macam tu, tapi mana silapnya? Kat mana?
Dia tak disperse evenly, dia macam tuang setumpuk benda.
Yes, correct. That's the answer lah. Okay, so the steel fiber has been dumped all at once. That causes it to clump. Kalau kamu tengok besi-besi, kalau macam paku kan nak beli kat kedai, dia melekat-lekat. So kalau steel fiber, you nak prepare steel fiber reinforced concrete, kita kena cerai-ceraikan dia. Maknanya letak sikit-sikit. Cerai-ceraikan dia, lepas tu letak sikit-sikit. Jadi dia boleh mix dalam concrete mix kita. Okay, so in this case, that's the Alamak, Pravina baru masuk. Okay. So, that's why lah. Okay. So, how do we avoid this kind of problem? We have to disperse when we want to mix the steel fiber inside the concrete mix, we have to do it stage by stage. Okay. And make sure the mix is homogeneously mixed. Okay. Alright, any question? Please read about the environmental pollution caused by the concrete industry. So kalau kita cakap concrete industry, kena be aware, bukan cement industry concrete industry. Bila kita kata concrete industry, sebenarnya dia ni banyak masalah dia sebab it is there because of other industries as well. There are other supporting industry for the concrete industry. So there are cement industry that produces cement to be binder in concrete. There are also industry that work for quarry the hill to produce aggregate which is needed for the concrete. That also causes pollution. Then there are also companies mining the sand in the river, okay, which also causes disruption to the environment. Okay, so if you ask about environmental pollution caused by the concrete industry, you boleh cakap banyak benda lah. So boleh even kalau markah dia 10 pun you boleh cerita lagi. Because there you can talk about the pollution caused by the oil, destruction caused by the cement industry during the quarrying, during the combustion of the limestone in the factory, okay, the dust from the factory. Okay, and then for the quarrying, you can talk about the removal of the rainforest or removal of the green areas before the quarrying work, and after the quarrying work, what happened? The area is exposed to the erosion, then the water quality got affected. Kenapa water quality get affected? Sebab dia ada air larian kan? Kalau macam kita yang nak balik KL ni, biasa kalau orang KL, orang Perak, kalau kita ambil highway ni, baru habis banjir kan. Ni best suitable time lah for you to travel. You can see the impact of erosion on the hills due to the deforestation activity, and you can, kalau macam ni memang kita boleh nampak lah how bad is the landslide or a landslide that takes place due to the removal of trees from that area. Okay, memang boleh nampak. Then you also can talk about the sand mining. Okay, sebelum ni saya nak bagi tahu, sand mining kita boleh korek pasir dekat sungai sebab ada juga pembisnes orang-orang jual pasir dia komen. Macam mana boleh cakap korek pasir merosakkan alam sekitar? Kita memang kena korek pasir. Yes, we can do the mining. Sand mining memang boleh buat because the magic of the river. Okay. Itulah dia God is great. Okay, so we are allowed to mine the sand from the river because there is a certain, dia ada saiz dia tersendiri di mana bila kita korek pasir tu akan ada pasir lagi yang akan terhasil. There is a cycle, okay. So kita dah korek pasir, akan ada satu proses di mana akan terhasil pasir-pasir baru, okay, untuk menggantikan pasir-pasir yang kita dah korek tu. Okay, it has the renewal rate, it has its own system to renew the sand that has been mined by us lah. Tapi it has certain rate. When we mine the sand excessively, excessively, korek beria, memang korek banyak-banyak lah. Bila kita korek excessively, pasir tu dia tak sempat nak renew. It doesn't have the time to renew itself. Bukan maknanya kan batu yang pecah-pecah daripada gunung, okay, on the way it will crash and become small fine particles. It takes time for it to be produced. So bila kita ambil banyak sangat pun, then it will affect the living aquatic life there. It will affect the water quality. It will affect the geography of the river. Okay, banyak effect lah. Okay, so which will affect the quality of the water and also the environment. Okay, even the fishes pun, there's certain fishes which is very, very sensitive. So once the water quality is affected, the fishes also disappear, go somewhere else. Okay. Okay, then we talk about the concrete industry. When we talk about the concrete industry, okay, from the concrete industry also there is water, polluted water that has been released. Itu pun pollution juga. Water, waste water from the concrete industry is also a part of the pollution to the environment. Okay. Lepas tu apa lagi? Those are the things lah. So kalau macam ni, it can go up to 10 marks kalau soalan macam ni. Okay, if the question ask you relate it with global warming, relate it with climate change. So you kena tahulah apa tu climate change, apa tu global warming. Okay, I believe most of you are aware about global warming, tapi climate change I think not many of you are aware about it. Okay, what are the factors that contribute to climate change, for example? Okay. Alright, so that's all for today's class. Okay. So see you on Friday lah. Okay, kita Friday pun kita akan bincang soalan-soalan final exam je lah. Okay.
Okay, Doktor. Thank you.